Right. Hello, everyone. So in this video, we will be discussing lab number 3. So I'm going to give you some idea of what you will be completing, what you will be doing in this lab. So guys, this lab basically, again, contains 3 parts for submission. One is your pre-lab submission. Then you got your actual lab report submission. And then you got the post-lab questions, okay? So if you look at the actual lab procedure, so this basically gives you the background on the nomenclature. So this lab focuses quite a bit on the nomenclature for the inorganic compounds and also talks about the Lewis structure. We have talked about this already in the lecture videos, so I will not be getting into details of how to name a compound or how to draw Lewis structures. For that, you're going to be referring to the lecture videos. Now, what I do want to discuss is where do you get all the data from for this lab and how you complete the lab report. Okay, so guys, what you will need is again, all these documents are provided to you on Canvas. So this is the data table. This is the table that you will need to download and complete and submit as a PDF on the lab report assignment. So what do you see here? You're given multiple ways on how you can actually complete this lab. So you have options to, download, fill it out on your computer, or use a digital pen on your computer. Or if you don't have that technology, then you can just print this out, handwrite all the answers, and then scan them and upload them back as a PDF. So what you're doing is, so this lab says, okay, you're given, so we have multiple tables here and you're supposed to complete all of them. So in this table, you see that you're given a compound name. You need to tell its appearance description here, and then you fill in the density, and then you fill in the melting point. So for the appearance description, you're supposed to refer to this second page. So this gives you all the pictures of all the compounds that are covered in that table. So for example, the first example was NABR. You'll be looking at NABR. This is the image for NABR. You will look at this picture and tell, okay, so I can see, first of all, this is solid. I can see it's in powder form. I can see it's white in color. I can see it's dry. So those types of features are what you're going to be discussing. And then you can also see you're also given the elements in the same list. You can see, for example, element sodium. This is what the picture of sodium looks like. So guys, the sodium, I can see this is shiny. It is gray or silver in color. So that's what you're going to be putting for appearance. Okay, so you can say whatever the texture, whether it's shiny or dull, what the color is, how does it appear? For example, this is powderish form. This is more like a solid, piece, like structure. Here I can see that there are granules that I can see are very fine granules. So you're going to be looking at all these different images, give as much detail as you can based on what they look like. Now, I just wanted to show you a couple of these examples here. So what you see here, guys, these are containers, and these containers actually have gas in them. And you can tell that here, this is O2 gas, or this container oxygen gas. So again, this gas, we can tell it looks, first of all, it is gaseous state. We can tell that it's clear, so you can see through it. I can also tell that it's colorless. It has no color. So it's not like yellow, green, blue color. It's colorless. So those types of the information is what you're going to be adding. So here you can see the color is different. So you're going to mention that for bromine gas. So all these this here, again, rock-like structure, crystalline form. So that's what you're going to be putting in onto these data table on the physical properties of all these different compounds. You're going to fill this in, and you're going to be uploading that where? You're going to be uploading it here. When you go to the data observation and end results, this is the actual place where you're going to be submitting all these. Guys, this is worth a lot of points. Make sure you're giving this enough time, because there are lots of tables you need to fill in, first of all. And then you need to also upload. So wherever it says upload the tables you filled out earlier, which includes the description, density, melting point. So this is where you're going to be uploading these tables. Okay, so we get the appearance and description from that picture page, but the density and the melting point, you'll be getting this by just looking up on Google or your textbook if you like. Okay, so that's, so you complete this and complete that table. Okay, now starting with the pre-lab. Okay, so this is the pre-lab assignment for experiment number 3. This one says that you're given different examples. We have done something like this earlier as well in the previous lab. So here it says, what charge will you expect for the metals of the following groups to carry? So if you're in group 1A, what charge do you expect? For 2A, what do you expect? 3A, what do you expect? Okay, and these are the examples that you're given, and also tells you how you're supposed to put in your answer so that Canvas can automatically pick your if your answer is correct or not. Okay, all right, so look at read the instructions carefully. Now here tell us if it's group 5 or group 6A, then what is the expected charge? What do you think? If it's going to be positive or negative, you have to figure that out. Okay, they're non-metals, so you guys decide what the charge is going to be. Then we are given the general example here. So we're given that you have metal M, which is coming from group 2A. It's reacting with non-metal, which is coming from group 5A. You're supposed to tell here what formula are they going to make. So the idea is that if I tell you I have metal M, so you just call it M, and if it's coming from group 2A, what is that group 2A telling you? It's going to tell you what the charge is. Okay, so M has the charge based on the group it belongs to. It then goes ahead and reacts with the non-metal N, and the N is going to have the charge based on its group number, which is 5A. So now, once you have the M as your ion and N as the second ion, then you guys decide how you will figure out the formula. We have done this again when we studied nomenclature for ionic compounds. So that's what you have to work on. Going to the next question. Again, this one says, what is the difference in naming cations that form, in type 1 versus type 2? We've done again something similar for experiment number 1 and in the beginning of this class. So again, decide type 1 or type 2. How do you what is the difference in their naming? Okay, so don't tell me the difference between type 1 and type 2 themselves. Don't tell me that one has just one charge and type 2 can have multiple charges. One is transition metal. So that's not what you're supposed to tell me here. You're supposed to tell me when you're naming them, then what is the difference? What is the difference in the rules when you're naming them? That's what you're supposed to explain. Okay, so that is it for the pre-lab. Now coming to the actual lab report. In this lab report, you're again filling in all these tables. The very first example has already been done for you as a guidance example. So the first example here is potassium. You're supposed to tell its atomic number of valence electrons. Does it gain or lose electrons when it forms an ion? If it does form the ion, what charge does it get? And what is the final symbol going to be? And when it forms the ion, what is that ion called? So based on this example, you're going to be completing the aluminum and calcium. So this should be pretty straightforward. Okay. Now, the next one here, it says this time it's picking the examples which are non-metals. So now you decide the same thing. So you're going to fill in, based on this example, fill in the chlorine and the sulfur. Okay, so this should be a pretty good review for your inorganic nomenclature. Okay, now this next question says, if I give you the name for the ionic compound and I tell you this is the positive ion and this is the negative ion, tell me what the formula is going to be. Okay, for example, if you start with Fe plus 2 with Cl negative 1, and if we try to get to the formula, how do we solve that? So for example, if Fe is plus 2 and Cl is negative 1, then we do the crisscross. Fe gets the 1 and Cl gets the 2, and FeCl2 becomes the answer, which is the formula. That's what you're expected here for all these examples. So here you also need to tell for calcium bromide, what is the positive ions? formula, what is the negative ion formula, and then give us the formula of the compound. Okay. All right. Then you got just more examples, and then you're going to be again naming them. Make sure you're focusing on the correct spelling. I would keep everything small letter so that again Canvas can automatically and correctly grade your assignment. Okay. All right. Again, make sure you're reading these instructions carefully when you're inputting your answer. This here is type 2 compounds. You're doing the exact same thing like you did already, okay? But for type 2 this time. Then you got, again, more type 2. You're naming them here. Then the next one, this one includes, again, polyatomic ions. So this one, you have both the ions, but this time one of them is a polyatomic ion. So now you're going to be putting in the formula for that, okay? All right, so these again should be pretty straightforward. We have already covered this in lecture. If you still have any questions, you can always feel free to email me, okay? But give yourself enough time when you're doing these assignments because they are going to be time consuming, okay? There's no limit to submit. I mean, there's no time limit to submit. So you want to sit in and submit it, it will take time, so start early. Okay, so then you are uploading, we already talked about this one, the previous document, which had all the appearance description, density, and multipoint. That PDF is supposed to be uploaded here. Okay, now we got the covalent compounds, and now you're going to be answering all these questions for the covalent compounds. So that's it for this question number 9. Now, when you go next, we are now dealing with the Lewis structures. And at the end, you will be actually submitting your drawings for the Lewis structure, okay? So here, you're supposed to tell me what is the electron geometry going to be, what is the bond angle going to be, how many number of bonded atoms do we have, what is the molecular polarity, whether the molecule is polar or non-polar. Again, this has been covered in Lewis structure chapters in quite a bit detail. So again, no. One thing I would want to mention here is that when you're looking at that table, which is discussed in the lecture, I gave you a PDF which actually contains, let me refresh this page so I can see how it looks like on, oops, not that. Reset. Give me 1 second. Let me actually go back here. I wanted to just show you that document, the handout that actually includes the different shapes. So this one right here, in week number 4. Because I'm on the student view, so that's why it's not letting me open. But you guys see, this is the document I'm talking about. So make sure you guys open that. You can download and open here. So this document basically contains the electron geometry and molecular geometry. So make sure they can be same or different depending on how many electron groups do we have, how many of those are bonded, and if we have any lone pairs or not. Based on that, you will see the electron geometry and molecular geometry. They could be same or different again, okay? So that's what you're going to be inputting here when it's asking you here. So it's asking the electron geometry and molecular geometry. So you're going to be, just dropping down and getting to the answer for that, okay? Oops. All right. Then we got the next question. This is again similar to what we have already talked about before. You got these metals, random metals. Did that open the pre-lab? Yeah, here. Reload. I don't need the pre-lab. Wait 1 second, guys. Let's go back here. Okay, so we were saying that you're going to be submitting your Lewis structure. I mean, you're going to be drawing the Lewis structures, and then you will be putting in the electron geometry, which is going to differ from molecular geometry. So just make sure you're paying attention to that, okay? All right, so you're going to be doing the same thing for different compounds here. Here we got the molecules which actually have 3 electron groups. And then the next category questions has 4 electron groups. And then again, you're going to be deciding what their answer is going to be for all of these. Now, make sure again that you're actually drawing the Lewis structures for these on a scratch paper and actually saving it so that you can submit it as a PDF later on, okay? And you're going to be doing that here in question number 13, okay? All right, now getting to the post lab, which is the final part for this lab. For the post lab questions, these are just general questions about the lab. It just says, using the appearance and the physical properties of the compounds. It says how different or similar do they look like when they actually become compounds. What's trying to say is that if you actually look at these pictures, do you notice that sodium metal looks like this? It looks very different from NaBr, from sodium bromide. So that's what you're going to be trying to explain here, that what difference do you notice, if you see any difference, when an element forms an ion and then forms a compound. And we can see that they look very different. So their physical properties and chemical properties will also be very different. Okay, so that's what we're supposed to explain here. Question number 2 says how to write down the formula for the ionic compound which contains type 1. Again, you're just explaining basically the rules for type 1 ionic compounds nomenclature. The next question is rules for nomenclature for type 2 metals ionic compounds. And then the final 4th question says how to write down the name for the covalent compound. So you're going to be writing down the rules for naming the covalent compounds. Okay, so that is it for this lab. If you guys will have any questions, let me know. Okay, that's it for this video. Thank you.